Hi everyone, in this video we'll be learning how to calculate classful and classless subnets. Subnetting is a very important concept in computer networking and beyond, but for new learners it can be very overwhelming and difficult to understand. So in this video I'll try to point out certain basic things I believe you should know before you expand your knowledge on the topic. So let's start by looking at what we need to know. So first of all, we have to know what an IPv4 address is. So an IPv4 address is made up of 4 octets, which has 8 bits each, and they are separated by dots. So this is the first octet, this is the second octet, this is a third, and that's the last. And this is in base 10, or what we call decimal. But normally, IP addresses are converted to base 2 or binary. That is what the computer understands. So 192, if converted into binary, will give you a combination of zeros and ones. You can either use a calculator, a binary calculator to calculate this. So you'd have 8 combinations of ones and zeros for 192. You also have the same for 162, for 100, and for 1. And we say that the first octet is what determines the class of IP. So depending on what the value of this octet is, will determine the class of IP. And this is mostly for classful subnets, which we will come to. So class A is normally ranges between 1 and 126. Class B ranges between 128 and 191. And class C ranges between 192 and 223. So if you take this example, that means this will be classified as a class C IP address. And the next thing we'd like to look at is a subnet mask. So a subnet mask helps you to map out the network bits and the host bits of an IP network. And classful subnet mask is what is mostly known as the default type, is where we all started from in IP addressing. So class A, according to the classful subnet mask, is represented as 255.0.0.0. Class B is represented by 255.255.0.0. And a class C is represented by 255.255.255.0. Though we have a class D and E, for IP addressing, we limit ourselves to these 3 classes. The other thing we should know is that in a subnet mask, the network bits are represented as 255, and the host bits are represented as 0. So 255 in these 3 subnet masks are representing the network bits of an IP address or a network. And then the host bits, those are the PCs, the routers, or anything that will be assigned an IP address, are represented as 0. The other thing we should know is that in binary, that is if you convert to base 2, network bits are represented as 1s and host bits are represented as zeros. So in this case, these are in decimal or in base 10, but if you convert it into 0, that means you have a combination of zeros and ones making up 8 bits. I hope you remember that from what we said in the beginning of this lesson. So 255 in decimal will give you exactly 8 combinations of ones. Remember we said that binary is a combination of ones and zeros, but the unique thing is 255 will give you exactly 8 bits of ones. There are no zeros. And the other thing is 0 in decimal will give you 0, so 8 bits of zeros. So the other thing we should know is that network bits can be represented using a slash notation or prefix. So the prefix is a slash, probably /8, /16, /24, but we have more in this. The slash notation is more relevant when we come to classless subnets, because here you have representations of ones, which are not just the network bits, but also subnet bits. So we'll come to that very soon. So just have in mind that all network bits and subnet bits are represented by a slash notation, but the host portion is not represented using a slash notation. Okay, so the next thing we would like to look at is some examples. So in this example, you have an IP address of 10.1.1.1.0. And because of this, you already know that it will be a class A, and the subnet mask for a class A IP address is 255.0.0.0. One thing I'd like to introduce here is calculating a network address. So if you have an IP like this, and then you have a subnet mask of 255 and the rest being 0, if you want to know the address of that whole network, you use every part of the subnet mask that is represented by 255, you bring its corresponding IP value as the network address. So in this particular case, you only have one portion of the subnet mask represented as 255. So in this case, the network address of that whole IP network will be 10.0.0.0. Let's take another example. So in this second example here, we have an IP address of 140.100.10.1, but the thing here is we have a subnet mask of 255.255.0.0. So in this case, we have two parts of the subnet mask having 255. So if you want to know the network address, you use its corresponding value in its IP octets. So we'll have 140.100 and the rest will be 0.0. So I hope you're getting the idea here. Let's take one more example. So in the next example, we have 192.100.10.1 and the subnet mask is 255.255.255.0. So in this case, we have three parts of the subnet mask being 255. So to know the network address, you bring its corresponding values in the IP address. So that will be 192.100.10, and the last value will be 0. This will become very relevant very soon. So I hope you understand up to this point. So let's look at this example down here. So in this example, let's just focus on the subnet mask. Although in an IP address, these are the basic things you would have if you do an IP config using the command prompt. It would give you an IPv4 address, it will give you a subnet mask, and it will give you a default gateway. These are needed to be able to use the internet or even communicate with machines on a network. So let's just focus on the subnet mask. So in this subnet mask, we have 255.255.255.240. And I hope you've seen something unique here. So the unique thing here is that 240 is not a 255 and it's not a 0. We are not used to it. And this is what we say when we talk about a classless subnet mask. So in this case, it's not a 255 and it's not a 0 in one of those octets. And that is what we'll be looking at next. So we want to look at classless subnet mask. And we are saying that classless subnet masks do not follow rigid rules of an IP class A, class B, or C. And it allows networks to be customized to requirements. So host bits are borrowed and converted to subnet bits. And if an octet isn't 255 or 0, then you should know that there has been a conversion of host bits to network bits. So it's not like the classful subnets that we know. So the decimal or the binary value of an octet depends on the number of bits that you've converted. And so this time we'll have an IP address which is not just divided into network bits or subnet bits, but we'll also, or host bits, but we'll also have subnet bits. So that's a new thing that has been introduced here. And this is a chart to show the number of bits that you convert from zeros to ones and its corresponding subnet mask value in decimal. So this will be very relevant as we go on. So if you convert just one bit, you have 128, 2 will have 192, 3 will have 224, 4 will have 240, 5 will have 248, 6 will have 252, 7 will have 254, and 8 will have 255. We are quite familiar with 8 because we have 8 combinations of ones giving us 255. But you may have an octet being 254, 252, 248, and as follows. So you should know that if you have these values, you can use this chart to identify how many bits were converted. So let's look at the example we have here. So in our example we have here, we have a .240 in the last octet. And mind you, always you'd only have one octet being peculiar. The other ones will be what we all know about. So in this octet, we have .240. And if we go to the chart, we have 240, meaning that 4 bits were converted. So that means that 4 bits were changed from zeros, which were supposed to be host bits, and converted into ones. And so we have the network bits being 24, which is what we all know. So 255 here will give you 8 bits, 255 8 bits, 255 8 bits. So that gives you a 24. And we have 4 converted bits, so that will give you the subnet bits of 4. And then we have the rest being 4 bits giving you a total of 32 bits for an IP address. So this can be represented as a /28. Remember we said a prefix or a slash notation represents the network and sometimes a subnet bits. So it represents all ones. And so in this case, subnet bits are also ones. So 24 plus 4 will give you a /28. So I hope you followed up to this point. So one other thing I would like to show you is how to calculate this chart. This chart is very important. It is very relevant. You should be able to either memorize it and replicate it off head, especially in a certification exam. But sometimes it will be difficult to memorize. So if you can't memorize it, I want to show you a trick that you can use. But first, let's look at these values we have here. So 128 in binary, if you use a calculator, will give you 1, 1, and then 7 combinations of zeros. 192 in binary will give you 2 1s and 6 combinations of zeros. 224 in binary will give you 3 1s and 5 combinations of zeros, until you get to 255, which will give you exactly 8 combinations of 1s. And that is what we have here. So you may be wondering why we have 128 and we don't have 129, following maybe 130, 131. That is because within a range of 256, and that is what we limit ourselves to in IP addressing. So between 0 and 255 or 256, the only values that will give you exactly these combinations that we want, borrowing 1 bit, 2 bits, 3 bits, will be these values in base 10. And that is why we use these particular values, because these particular values are only the ones that will give you 1 bits, and then 2 of 1s, and then 3 bits of 1s, 4 bits of 1s, all the way to 8 bits of 1s. So I hope you're getting it up to this point. And you also realize that 1s are all to the left and all zeros are on the right. You don't have 1s interleaving the zeros. And that is how it is with an IP, subnets, and borrowing of bits. I would like to show you the trick in computing this table, especially if you cannot memorize it. But if you can memorize it, you don't need to use this trick. So what you have to do first is know that you use 128 as a reference point. It's non-negotiable. You should know that 128 is a reference point if you are converting 1 bit. From here, things become easier. So the next thing you do, if you know that 128 is a reference point and it means that 1 bit has been converted, is to divide 128 by 2. And if you divide, you have 64. And you add that 64 to your reference point 128, and then you have the answer for the second bit. That's 192. The next thing you do is convert or divide 192 by 2. That'll give you 96. And then you add it to your reference point, and that'll give you 224. That's the value for the subnet mask if 3 bits were converted. The next thing you do is to divide 224 by 2, and then you have 112. And then you add that to your reference point again. And then you have the answer for your 4th bit, which is 240. So I guess at this point, you know what we'll do next. We divide 240 by 2 and then add it to our reference points. And if you do that, you should be able to fill this table very easily. So you use this table if you use this formula, if you cannot easily formulate or memorize the table. But if you can, there's no need for this table. So the next thing we would like to look at is how to calculate the number of subnets created. And this is dependent on the number of bits that you borrow. So the formula is 2 raised to the power n, where n is the number of bits that you've converted or borrowed and converted from 0 to 1. So if you convert just 1 bit, you have 128. If you convert 2 bits, you have 192. 3 is 224 all the way to, if you convert all 8 bits, which is 255. So let's go back to the example we looked at earlier. And in this example, we had .240. So in this case, it means that 4 bits were converted. So if 4 bits were converted using this chart, it will be 2 raised to the power 4, and that will give you 16 subnets. So it means that you can create 16 subnets if you convert 4 bits. If you convert 5 bits, it will be 2 raised to the power 5, and that should give you, I think, 32. Yes. So I hope you're getting it up to this one. This is how to know the number of subnets that you can create depending on the number of bits that you borrow. So the next thing we want to look at is calculating the subnet size. So depending on the number of bits you borrow, it will determine how big a subnet can be. So we're saying here the formula is 2 raised to the power h, where h is the number of bits remaining. So after converting the bits, the number of bits, host bits that remain after converting some of them is used to formulate the subnet size. So if you have more host bits, that means you would have converted less of the bits from zeros to ones. But if you have less host bits, it means that you have more conversion of bits from zeros to ones. And the other thing you should know is that if you convert more bits, it means that your subnets will be bigger, but your IPs will be smaller. And you realize that very soon. So if you're converting 1 bit, you have 7 bits remaining. So that will mean a 2 raised to the power 7, because you have 7 host bits remaining because you only used 1. So that will be 2 raised to the power 7, which will give you 1 to 8. And that's what we have for the first one. But I like to start from the bottom. So if you have converted all 8 bits, it means that you have no bits remaining. And in this case, that means it will be 2 raised to the power 0, which will give you 1. And that's what you have here. So if you convert 7 bits, it means you have 1 bit remaining. And that would have been 2 raised to the power 1, which would have been 2. That's what you have here. So you realize even here, there's a trend here that makes it easier. You have 1 and then you have 2, and then you realize that it's a multiple. So 2, and then 4, and then 8, and then 16, 32, 64, 1 to 8. So you can just start from 1 and then use the pattern to formulate this table if you want to. But this is the formula. If you want to formulate with using the formula, you use 2 raised to the power h, where h is the number of host bits remaining after converting some of those bits. So the next thing we want to do is to look at the example that we used. So in here, we go back to our example and we have 240 as the last of the .240. So if that's the case, we know that we've converted 4 bits and we have 8 bits, meaning that we'll have 4 remaining. So in this case, that means we have 2 raised to the power 4, which means we have 16. And that will be the size of each subnet. Okay, so the next thing we'd like to look at is an example. And before we do that, let's look at some terms. So in this case, we'll be calculating the subnet addresses, the first host, the last host, and broadcast address. So let's look at what we mean by these terms. So a subnet address is the first IP address of a subnet. So normally we should take note that it starts from .0. That's the first IP, the subnet address for the first subnet. The next will start from the next range depending on the subnet size. So if you have maybe a subnet size being 16, the first will always start at 0, the second one will start at 16, and then becomes a multiple. So we'll use the example and you probably will understand it better. But the next thing we'll look at is the first host address. So that's the first IP after a subnet address. So in every subnet, we have 2 addresses which are reserved, the subnet address and the broadcast address. So the first host is the first assignable IP address to any host. And that is what we talk about here. The next thing we look at is the subnet broadcast address. So it's the last IP address of a subnet. So this is also reserved. You cannot use it. You cannot assign it to any host. But the last host address is the last IP before the broadcast IP or the broadcast address. So it's a broadcast address minus 1, whereas the subnet address is a subnet address. The first host address is the subnet address plus 1. Okay, so let's look at an example here. So in this case, we are going to be calculating the subnet address, the first host, the last host, and the broadcast address. So let's say we've been given a question like 171.16.35.123/20. That's all we are given. And we are to use this to calculate the subnet address, the first host, the last host, and the broadcast address. So in here, it's easier with a slash notation to derive the subnet mask that we are familiar with. So this is how the subnet mask will look. So we have 255.255.240.0. And let me explain. So we said we have /20. So we all know 255 means we have 8 bits of ones. So the first octet will be 8, the second will be 8, and that will give you 16. So we have 4 more to reach 20. Ideally, or by default, we should have had another 255, and that would have given us /24. So if you're not having 255, it means that this is where some borrowing of bits are taking place in the third octet. So some bits have been borrowed and converted into ones. So originally, this octet should have been for the host portion of the network. So in this octet, we have to determine how many bits were borrowed from zeros and converted into ones. So we look at 240 and go to a chart. So that's where the chart becomes very relevant. So 240 means that 4 bits have been borrowed. So if 4 bits were borrowed, that is why we have its corresponding value as 240 here. And the last octet is 0. And 0 we know is the host portion of the network. So using this information, we want to calculate the number of subnets that we can have after converting a number of bits. So if I identify 240, meaning that we have borrowed 4 bits and converted them into ones. So in calculating the number of subnets, it becomes easier. The number 2 is about the number of subnet bits that you borrowed, so 4, and that will give you 16. And the subnet size, the size of each subnet, that will be 2 raised to the power the number of host bits remaining. So after borrowing 4 bits out of a possible 8, we have 4 remaining. And that will mean that 2 raised to the power 4 will give you 16. So from here, we should be able to determine the possible subnet addresses that we will have, knowing that we have a subnet size of 16, and we know that we have a possible 16 subnets. It should be easy for us to determine where each subnet will start. That's a subnet address. So remember we said earlier that each subnet address starts from .0. So that's always the first subnet address. So the first one will start from .0, and we know that the subnet size is 16. Remember, .0 is inclusive. So .0 to .15 is 16 IPs in that subnet. That's the size. So the first one will be .0, and then the second one will start from .16, and from the 16 you count another 16, and so remember .16 is inclusive, so it will end at .31, and then .32 starts another subnet address, .48 another, .64, .80, all the way up to 240. So always remember that .0 is the starting subnet address, and then you use your subnet size to determine the next subnet address and the following. So the range will look something like this. We have the first one ranging from .0 to .15. That's for this third octet. And then the next one will be .16 to .31. And then we have .32 to 47, all the way to .240 to 255. Now we have to calculate 4 things, remember. So we are going to be calculating the subnet address, the first host, the broadcast address, and the last host. So let's go on to that. So in calculating the subnet address, we've already identified where each subnet starts. Now, what we have to do is to start with the network address. So the first 2 parts of calculating a subnet address is similar to what we calculated when we're doing the network address. So we have it being 171.16. Remember we said wherever you have .255, you represent that. You also use that when you're calculating the network address. So the first 2 parts will always be the same, provided you have .255 on the subnet mask. So it's the third octet where it's a bit tricky. So .240, we've identified that it means 4 bits were converted. We've identified the subnet size. We've even gone ahead to identify the subnet addresses and its range. So now, in calculating this third octet, we look at .35 on the IP address, and we have to determine in which part of these subnet addresses and this range does .35 fall. So if you go to your range, which you've computed, you realize that .35 will fall in this range between .32 and .47. That is where .35 on the IP address will fall. So remember, we are calculating the subnet address. And I should mention that we identify the subnet addresses 0.16.32, and we've identified a range. And this is the subnet address, but this is the broadcast address. So this is the first address, and that's the subnet address. And the last address for that subnet becomes its broadcast address. So these two addresses are always reserved. You cannot assign them to any hosts. You always reserve these. So it means that in this range of possible 16 IPs, you have only 14 assignable IPs. So let's go back to what we are saying. So in identify the subnet address, we will put .32 as the next value here, because .32 is the starting point of this subnet, and that's a subnet address. And the last octet is very simple. Once you have 0 on the subnet mask, you represent it as 0. That's the host portion. So it's always 0. That's if you're calculating the subnet address. We'll come to the broadcast address and you realize that it's a bit different there. So the first host, as we said, is the subnet address plus 1. So the first two will be the same, the third octet will be the same, and the fourth octet, if your guess is as good as mine, will be 1. So I hope you're getting it. The next thing we'll calculate is the broadcast address. Again, the first two parts will always be the same. Wherever I have 255, it's just like calculating a network address. So there's a third octet that we mostly will concentrate on in this example, because that's where the subnetting is taking place. So in this one, the broadcast address, it will be .47. And guess why? It's because we've already identified the range of interest, and for the subnet address is the starting point of that subnet. The broadcast address is the ending point of that subnet. So in this case, it will be .47. And that's what you represent here. And the last octet is what I wanted to drive at. In the subnet address, you realize that if the last octet is 0 here on the mask, it's also 0 as a subnet address. But if the broadcast address as a 0 on the subnet mask, it will be 255 here. So that's the difference. With the subnet address, it's always 0, but here, once it's 0, it's 255 for the broadcast. So the last thing we'll calculate is the last host. The last host, remember we said, is the broadcast address minus 1, broadcast address minus 1. So that will be 171.16.47.254. So we have come to the end of this quick overview. I hope I have expanded your knowledge on the topic, and from here it will be easier for you to expand your knowledge.